Quadrilateral ABCD has vertices A 5, 1, B negative 3, negative 1, C negative 2, 3, and D 2, 4. Show that ABCD is trapezoid and determine whether it is an isosceles trapezoid. The first step in such question, we must graph the figure. We graph it here. We plot each point, then we match between them. The definition of trapezoid, we have one pair of opposite sides are parallel. To prove that this figure is trapezoid, I must prove that CD and AB are parallel. How I prove them? Of course, it's very simple. We study the rule of slope. You remember it. M equal y2 minus y1 over x2 minus x1. I use this rule to find the slope of CD and the slope of AB, here about A. When you find the slope of CD, then you find the slope of AB and you get the same slope. This means the two segments are parallel. When lines or segments are parallel, if they have the same slope, we studied this before many times. Then again, you use the rule M equal y2 minus y1 over x2 minus x1 for CD, and the same rule for BA. If you get the same slope, you can say that CD parallel to AB. If they are parallel, this means the figure is trapezoid, because the definition of trapezoid is a quadrilateral that has one pair of opposite sides are parallel. Now, determine whether it is isosceles trapezoid. To prove it is isosceles trapezoid, we have two ways. First, you can find DA and CB. Again, you use the rule of distance to find DA and CB. If they are congruent, then this trapezoid is isosceles trapezoid. Or you can find the diagonals. You can find DB and CA. Also, if the two diagonals are congruent, this means it is isosceles trapezoid. Then you have two ways. You can choose any one you want. If you want to prove that DA and CB are congruent, it will be isosceles trapezoid, or diagonals DB and CA also, if they are congruent, then the figure is trapezoid. Here, as you can notice, slope of AB 1 over 4, slope of CD 1 over 4. We have one pair of opposite sides are parallel, AB and CD, so ABCD is trapezoid. Of course, I don't care about AD and BC because I can notice they are not parallel. But in the question, he finds the slope of the four sides. After he finds the slope of the four sides, he can say that AB and CD are parallel because they have the same slope. One pair of opposite sides are parallel, then the figure is trapezoid. Here, he used the rule of slope. Now here, use the distance formula to show that the legs are congruent. We go back. This legs, CB and DA, they called legs, and CD and AB are called bases. Here he used them. AD equals square root of 18, BC equals square root of 17. The legs are not congruent. This means ABCD is not an isosceles trapezoid. To be isosceles trapezoid, this means AD and BC must be congruent. And as you can see here, they are not congruent. This means it is not isosceles trapezoid. Here, boys, the same question exactly. I want you to solve by yourself. I want you to graph. Then I want you to check if the bases are parallel or not. If they are parallel, you say it is trapezoid. Then you check the legs or diagonals. As I said, you are free. If they are congruent, it will be isosceles. Not congruent, it is not isosceles. Of course, the answer is here, but I want you to get the answer by yourself. Now we are going to talk about mid-segment. mid-segment theorem, the mid-segment of trapezoid is parallel to each base, and its measure is 1/2 the sum of the lengths of the bases. Very simple. AF and CD are bases. When I draw mid-segment BE, this mid-segment BE, B is midpoint of AC. Again, B is what? B is the midpoint of leg AC, and E is the midpoint of leg FD. This segment, which matches between the midpoint of the two legs, are called mid-segment. What is the properties of this? It has two properties. First one, it is parallel to the bases. This means BE parallel with AF and BE parallel with CD. This is the first property. The second one, the measurement of BE is half of the sum of the two bases. This means BE equal AC plus CD divided by 2. Again, what is the measurement of BE? It is the measure of AF plus CD, then you divide the sum by 2 here. BE equal half times AF plus CD. Example. If the figure MN is the mid-segment of trapezoid FGJK, what is the value of X? Of course, here X is what? It's base. MN is mid-segment. KF is base. The rule said what? Mid-segment equal base 1 plus base 2 over 2. I substitute, this means 30 equal 20 plus X over 2. We solve it, we get the answer. You see? He writes the rule here, then he substitute. We have this equation, we solve the equation, we get the answer X equal 40. Of course, can I solve it mentally? Of course I can solve it mentally. How? Listen how, it's very important and it make your work very simple. If you have, or if the mid-segment is given and he wants you to find one of the bases, you make two steps. Multiply the mid-segment by 2 and subtract the given base. How? Mid-segment is 30. 30 times 2, 60. 60 minus 20, it is 40. Direct. You don't need to do all of this equation. Again, how you find one base if the mid-segment is given? You multiply the mid-segment by 2, then you subtract the given base. Mid-segment is 30. 30 times 2, 60. 60 minus 20, 40. I get the answer direct. I don't want to make all of this equation. Here the same. WXYZ is an isosceles trapezoid with median JK, or mid-segment he mean, of course. Find XY if JK 18 and WZ 25. Direct. 18 times 2 minus 25. Of course, 18 times 2, 36. 36 minus 25, the answer is 11.